Hi class. This diagram that I'm going to draw for you now actually goes with the material from section 5A, but I wanted to cover wavelengths and frequencies because I think this diagram will make a little more sense to you having that background on wavelength and frequencies. So I wanted to draw for you solar radiation being emitted by the sun. Obviously it's solar radiation, and the 7 forms of radiation that comes from the sun. And so I'm going to be very careful about how I draw this. Okay, so if you're drawing along too, be aware of what it is I'm trying to show you here. So the sun emits 7 forms of radiation. In science, we know of 7 forms of radiation, and the sun emits all 7 forms. So the first form is gamma radiation. And again, I'm going to try to draw this very carefully. And when I say I'm going to draw this very carefully, it really doesn't make much sense to you until we get to the next guys. Okay, so this is gamma radiation. Okay, it also emits X-ray radiation. And so X-ray it's going to have a little bit longer wavelength. So that's what I'm trying to show here. A little bit longer than gamma radiation. And this is X-ray radiation. Okay, next is ultraviolet radiation. So that has a little bit longer wavelength still. UV, or ultraviolet radiation. Okay, next will be visible radiation. Again, has a little bit longer wavelength still. Okay, next comes infrared radiation. A little bit longer still. Infrared radiation. Going off the page there a little bit, sorry. After infrared radiation comes microwave radiation, so that's going to have a longer wavelength still. Microwave radiation. And last is going to be radio wave radiation. That has the longest wavelength of all. So I was careful to write radiation, or rad, short for radiation, after each form of radiation, because oftentimes you hear the word radiation and there are certain connotations that come with that word. It scares a lot of people. A lot of people think immediately, if you plain word association, they associate radiation with cancer, and certainly that is a possibility in with certain forms of radiation. And so you have to be really, really careful with some of this. So let's apply some of the concepts that we learned before. Okay, and so on the previous video we had said that the shorter the wavelength, the higher the frequency, the higher the frequency, the higher the energy content. So we're looking at this end of the scale here, gamma rays, X-rays, and ultraviolet. These are going to have the shortest wavelength. Okay, having the shortest wavelength, these are going to have the highest frequencies. Having the highest frequency, then these forms of radiation will have the highest energy content. And so these are the forms of radiation you need to have a healthy respect for. On the previous video, I had mentioned X-ray radiation. When cancer patients go through radiation treatments, they're being bombarded with gamma radiation. So gamma radiation is used to not only kill cells, but gamma radiation can also cause the cancer that you're trying to get rid of in radiation treatments. And so it's both good and bad, but it is the highest. It's got the shortest. Oh, I forgot the T. It's got the shortest wavelength. It's got the highest frequency and the highest energy content of any form of radiation. Ultraviolet radiation is what we receive when you go down to the beach. And so you really need to be careful. So when the human body absorbs ultraviolet radiation, it gives us the suntan that a lot of people desire. But if you absorb too much of it, it gives you a really bad sunburn, and it could be the beginning of cases of melanoma, skin cancer. So you got to be really careful with ultraviolet radiation. Okay. Let's see, the microwaves and the radio waves down here. These have the longest wavelengths. Having the longest wavelengths, they have the lowest frequency. And having the lowest frequency, these have the lowest energy content. So again, on the previous video, I had mentioned, we don't worry about the radio waves that are all around us that are being given off by radio stations, because they have such a long wavelength and a low frequency and therefore a low energy content. They're harmless, and so we don't have to worry about those. Okay, there's one more thing I want to mention, so I'll move this over a little bit. So the sun emits 7 forms of radiation, but again, I don't want you to get the idea that it's 1/7 gamma rays, 1/7 X-ray, 1/7 ultraviolet, and so on. It's not, okay? The sun does emit all 7 forms of radiation, but in varying amounts, okay? And so what I mean by that is if we combine gamma radiation, X-ray radiation, microwaves, and radio waves. Now this is energy being given off by the sun. Okay, all of these combined account for 1% of the energy being given off by the sun. Okay, combine gamma rays, X-rays, microwaves, and radio waves. All of those forms of radiation combined make up only 1% of solar energy. Okay? Visible radiation makes up 43% of the energy that reaches the top of the Earth, top of the Earth's atmosphere, of that solar radiation that travels through space. Okay? Infrared radiation makes up 49% of the solar radiation that reaches the top of the Earth's atmosphere. So just combine visible and infrared radiation. That's 92% of the solar radiation that reaches the top of the Earth's atmosphere is in either the form of visible radiation or infrared radiation. 92% of the solar radiation that reaches the top of the Earth's atmosphere is either visible or infrared. Okay? And so that leaves ultraviolet radiation is about 7%, About 7% of the solar radiation that reaches the top of the Earth's atmosphere is in the form of ultraviolet radiation. And as we mentioned in Chapter 2, a lot of that ultraviolet radiation is absorbed by ozone in the stratosphere. Okay? Again, that's why the stratosphere warms up, is because of the absorption of ultraviolet radiation. So even though ultraviolet radiation has a short wavelength, a high frequency, and a high energy content, and you still need to be careful when you're outside because of ultraviolet radiation, but a lot of what we receive from the sun is absorbed in the stratosphere, which is why the ozone up in the stratosphere is so important. Okay? So this, again, I get geeked out by this stuff. This is really cool. So if you have questions, let me know. Take care.